Hi everybody, and welcome to the next video on functions. In this video we explore the interaction between vectors and arrays and functions. And so to make that more precise, just recall sort of the global way that you declare a function. The first thing you have to do is decide whether or not your function returns anything. If it doesn't return anything, then your function is void, and you would write a void right there in the space that's highlighted. But if your function does return something, you have to tell the computer what the data type of that returned thing is. So you have to tell the computer, look, you're going to spit back an integer, or you're going to spit back a true or false because you're a Boolean function, whatever. So you have to tell the computer what kind of thing it's going to return. You have to tell the computer what the name of your function is, and then you have to tell the computer what you're going to hand to the function and what the data type of each of those things is. So you have to tell the computer, look, I'm going to hand you a couple of integers and a decimal, or I'm going to hand you a couple of strings and several characters. Whatever your function does, right, determines what you're going to hand the function. So all of that just to say, you have to declare what kind of thing you're returning. You also have to declare the number of parameters that you're going to hand the function and what the data type of each of those parameters is. Okay, well, these data types right here or right here don't need to just be ints or strings or bools. You can return a vector or an array if you want to. You can also pass a vector or an array as a parameter. So the point of this video is to illustrate several examples of this and just to illustrate how useful this can be. Sometimes it's really useful to pass a vector or an array to a function, and sometimes it's really helpful to return a vector or an array. So in particular, here are 4 examples that we are going to look at. The first example will print a vector, so we will write a function that does that. In the next example, we will write a function that will calculate the median of a vector. And the final 2 examples have to do with computing divisor lists. So this maybe looks confusing right now, but when we get to it, we'll flesh this out. So that's what we're going to do. Okay, so let's start with this first example here with printing a vector. Oh, oops. I don't know how that got in there. That's my daughter. Sorry, that's embarrassing, just leaving these photos lying around like that. I don't know what that's doing in the slides, but as long as we're here, notice how cute that she is. Okay, so let's write a function that prints an integer vector. So whenever you want to write any function at all, the first thing you need to think about is you need to think about the global scope of your function. Like, what is your function going to do? And in particular, is it going to return anything? If so, what is it going to return? And then on the other hand, what are the parameters I'm going to hand the function? So in other words, before you even write the function, you need to think about, what am I going to write right here? Am I going to write void, int, a vector, whatever? And then you need to think about, what am I going to write in here? What do I hand this function? Do I hand it a vector? Do I hand it an integer? Whatever. You have to think about those things before you even write the function. And in this particular example, all you're going to do is print the vector. You're not going to do anything else, which means you don't need to return anything. You don't need to return a number. You don't need to return another vector. You don't need to do anything like that. You just need to print. So it's going to be a void function. You do, though, need to hand the function a vector to print. Right? So here we're telling the computer, I'm going to give you a vector. You're not going to return anything, though. Okay, so let's now write a function that prints a vector. I already have a vector going here in main just so we can test our functions on this vector. And up here before main, let's now declare our function. So print vector, and then we have to tell the computer we're going to hand you an integer vector. Okay, so now let me write the function down below. Okay, so basically all we're going to do is we're just going to write the for loop that we always use to print a vector. And that for loop looks like this. You just start at position 0 and you go up until you reach the end of the vector, and you just output the individual entries at each spot, and maybe you put a space in between. So notice back up here in main, if I wanted to print this vector, I could write this. I could write for int I equals 0 and I less than this vector dot size. You know, in this case, this number is 5, but suppose you forgot that it was 5. You could always just write this and print that vector, right? This vector I, and put a space in between. So let's just confirm that this for loop does what we say it does right here. And of course it does, because we've been dealing with this for loop for like a month now, right? So this is comfortable. But suppose that throughout this program you want to print lots of integer vectors, and you get really tired of writing this line of code over and over again, right? This little for loop. Instead, what you can do is you can take this for loop and segment it into its own subroutine. That's all we've done here. We've just taken this for loop and written it down here, and now if I want to print this vector, I can just write this line of code. Please print this for me. Now what happens is I pass this vector right here into this function. This vector replaces myvec. So myvec takes on the role of this vector. And so when this for loop runs down here, myvec is this vector. And so you're going to print this vector right here. So let's just confirm that this works. Okay, it works. So I want to mention a couple of things before we move on. First of all, notice again what this function is doing. Why use functions? Because it lets you take a certain segment of code that you might have to write over and over and over again in main, and it lets you take that code out and separates it as its own little subroutine that you call on when you need it. So rather than writing this little for loop structure a dozen times up here in main, you can just write this for loop once and call on it when you need it. So that's the first thing to notice. The second thing I want to mention is, if you look at code written by real programmers, and by real programmers I mean people not like me, right? I'm not really a programmer. If you look at real code in industry, a lot of times what you'll see is main itself is fairly short. The main function is fairly short, and what you read inside of main looks almost like just regular English. So this statement right here, for example, just looks like English, right? You can read this, print vector, this one, right? What vector do you want me to print? Well, the one that's sitting right here, right? So what real programmers a lot of times will do is they will just write very global things here in main, right? I declare this vector, now I want to print it, now maybe I want to do something else with it, and so on. And they will save sort of the gritty details, the sort of nuts and bolts of the program. They will separate those nuts and bolts out and put them in functions here. One of the reasons they do that is to make their code readable for other programmers. So another programmer will come along and look at the main subroutine, right? Just look at main, and since it's written almost like in English, another program can tell what should be going on inside of this program. And then if the programmer wants to really dig into the program and see what's going on, this other programmer will scroll down and look at the separate functions, right? But in any case, in industry, it's sort of considered nice to have your main subroutine just very readable and just have functions up here that you call on, and then if somebody else wants to, they can go down and see what's inside of those functions. But if you have named your functions appropriately, then some other programmer should be able to tell what's going on without even having to look at the code inside of the functions. Okay, so now let's move on to our next example. The next example is to calculate the median of an integer vector. And so again, let's think about what kind of thing am I going to return, and what kind of thing or things am I going to hand to this function? Well, in this case, you're going to hand the function an integer vector, right? That's what you're going to feed into the function. And what comes out is going to be a median value, right? But remember, even if you start with integers, the median of a list of integers doesn't necessarily have to be an integer. So the median sometimes is a decimal. So here's how we're going to declare this function. I'm going to return a float, because the answer could possibly be a decimal, and I'm going to hand the function an integer vector. Okay, so let's now come to my code here, and yeah, so median is what I called this. So float median vector int, and again, let me just call it myvec. You can call it whatever you want. Like always, this name right here is simply a placeholder. Okay, sorry about all this up here. I cannot control that. Okay, so now let me write the function down here. And the code that I'm going to put into this function is essentially what you guys have already written, because you guys have already written a program that calculates the median of a list of integers. So I'm just going to put that code now down here in this function. If you want to calculate the mean of a list of numbers, the first thing you have to do is sort those numbers from smallest to biggest. So that's what this line of code does, right? It sorts from smallest to biggest. And now once the numbers are sorted, if you want to compute a median, you first have to ask yourself, well, is the number of numbers in this list odd or even? Because if the number of numbers is odd, I just literally pick off the middle value, and that's the median. But if the number of numbers is even, then I take the average of the two middle values. So again, this is something you guys have already done, so I'm just going to go ahead and fly through this, but let me just say that if the number of numbers is odd, so when I divide it by 2, I get a remainder that's not 0. Then what I want to happen is I want to return the guy that's right in the middle. So the guy that's inside of my vec at this particular location, size over 2. Okay, so what's happening here? Let's just say that the size of my vec is 5. Right, so you have 5 entries in your vector. Well, 5 is odd, so you will enter this if statement here. 5 divided by 2 is 2.5, right? But this size value here is an integer, and the 2 is an integer. So the computer is going to do integer division, and so 5 divided by 2 is 2. So we're going to return the entry of the list at position 2, and that entry is right in the middle of the list, because you count 0, 1, 2, 3, 4. So if you have an odd number of numbers, this code now will just return the guy that's right in the middle. Otherwise, though, we need to return something else. We need to now look at the average of the two guys in the middle. So let me just write code that does that. I'm going to return the average of the two middle guys. So what does that code look like? Well, it looks like this. And again, I'm just going to do this because you guys have done this already yourselves. So here are the two middle guys. And I have to average them. And I have to make sure I return the real average, not the integer average. All right, so I cast to float right here. Okay. It acts like it's mad at me. Oops, my vec, right? Okay, so again, what's happening here? This first expression here is for the entry of the vector at this particular position, the size -1. Oh, oops, I'm sorry. I have to go to the middle and then look at one less. Sorry. And then here I have to go to the middle. I apologize for those of you who take your notes in pen. So what is this saying? It's saying go right to the middle and then go one to the left of the middle and then go one to the right of the middle. So you have here the entry at position size over 2 -1. the entry at position size over 2, and then I'm going to average those two values. And again, you probably haven't thought about this for a little while, but this is what most of you did on the program where you calculated a median for a list. So all I've done now is take your code and put it in a separate function, and now I can come back up here and let me not print the vector anymore. Let me now just print the median. So just ask the computer, what is the median of this vector? And before we print this, let's make sure we know what the median is. The median is 2. Right, so negative 5, 0, 2, 3, 7. So we're expecting to see a 2. And we do. Okay. So just to make sure this works with an even number of numbers, let me tack on an extra value, put a negative 1 there. And now let's print the median and see what happens. Yeah, so is that what we were expecting? Yes, negative 5, negative 1, 0, and 2 are now the two middle values, and the average of 0 and 2 is 1. Okay, so again, what have we done? We've taken the task of calculating a median, and we've separated that task out into its own separate subroutine that we can call on whenever we feel like. So suppose that for whatever reason, maybe you're writing a program that can deal with all sorts of different data sets and you want to start comparing medians of different data sets. It would be obnoxious to have to keep writing the median calculating code every time for each data set. So instead, you just write the code once, and then for each data set, you call on this function when you want to know its median. So it streamlines the code, and again, it makes main more readable. In English, you can all read exactly what this is saying. Please print for me the median of this list. So it makes main just more friendly, right? More user-friendly for some other programmer that wants to come in and see what's going on. Okay, let me go back to my example here. So we're now done with this example, so let's move on. Oh, and then another picture of my daughter snuck in there. This is her derp face. So we're not sure what's going through her brain when she makes that face. Dr. Seuss was befuddling her, I suppose. Okay, so now let's do this. Let's write a function that computes a list of divisors given a number. So what do I mean by this? I mean I want to hand a function a number, like say 10. And I want the function to return a list of divisors of 10. So what does that look like? Well, I'm going to hand the function an integer, and what do I want back? What I want back is a list of divisors. So if I hand this function the number 10, what I want back is the list 1, 2, 5, 10. Okay, those are the divisors of 10. The positive divisors, I suppose. We only care about positive divisors. Okay, so let's write a function that does that. So in this case now, we're going to return a list. We're going to return an integer list, divisors, and I'm going to hand it a single integer. Okay, so let me now come down here and write this function. So let me just first declare a vector, integer vector that's just going to keep track of the divisors. And so now, how can you create a list of divisors? Oops, let's start at 1, and let's go up to the number we're handing the function and go 1 at a time. Well, all we want to do is we want to check if the current I value is a divisor of this A value or not. And if it is, we want to throw it into this vector x. So that code looks like this. If the number I'm currently thinking about is a divisor of A, so again, in this case, A is like 10, right? That's the number you're handing. Then what do we want to happen? Well, we want to throw that divisor into my list. So basically, this vector x, I'm just creating it from scratch every time I get a hit, whereby a hit I mean a divisor of this A, then I just throw that number into this list. And then when I'm done, I'm going to return that divisor list. Okay, so let's come back up here, and let's now do something like this. Let's create a new vector, whatever, divisors, although I don't want to use the same name as my function, right? Let's just call it divs. And let's do this. Let's say that divs is going to be the divisors of, let's say, 12. And then let's print, vector. Let's print this vector that we've created here. So, okay, what are we expecting to happen? Divs right here is just an empty vector. I haven't done anything with it. But right here, what am I saying? I'm saying take the number 12 and feed it into this divisors function, right? So 12 is going to get fed in as a. So what this for loop should be doing is just calculating all of the divisors of 12 and throwing them into this vector x, and what gets returned is the vector x. So the return value is a vector. That's why, for example, this equal sign makes sense. Okay, I've inputted a 12, but what's coming back to me is a vector. So what's on the left-hand side of this equals is a vector, and what's on the right-hand side of this equals is a vector. Notice if I try to do something like this, suddenly the computer is not happy with me anymore. Okay, and the reason is because this right here, what is this? It's a list, right? This is a vector. I've fed in 12 and I've gotten a vector back. This on the left-hand side is not a list. It's just a single integer. So you have to be careful when you're using functions that if you write equals like this, like I have right here, that what's on the left-hand side really is the same data type as what's on the right-hand side. Okay, so now let's just print this and see if we get what we think we should get. Close. There's an extra 1. Why is that? Oh, because I still have this printing of a median command down here. That's why. Okay. All right, so I get what I want. So these are the divisors of 12, the positive divisors. 1, 2, 3, 4, 6, 12. Numbers like 7 are not divisors of 12. 12 is not a multiple of those numbers. Okay, so here is an example of a function that returns a list, right? A given number, a number like 12, has more than one divisor. So if you want to store those divisors someplace, you can't just use an int or a float or whatever, right? You have to use a list. If you want to store multiple numbers, you need to store those multiple numbers inside of a list. Therefore, this function must return a list. And that's why we have it returning a list, right? And in particular, what kind of list does it return? It returns an integer list, right? Because the divisors of an integer are other integers. So here's an example of a function that takes a number and returns a list. So let's now do our final example. This is going to sound kind of confusing, so let's flesh this out for a second. But I want to compute a list of common divisors given a list of numbers. So to be precise, here's what I want the function to do. I want to hand it a list of numbers, and the function returns a list of numbers that are common divisors of everything in that list. Okay, so that's probably still confusing. So here's what you want to focus on. Here's a list of numbers, right? 6, 12, and 30. These three numbers have some divisors in common. Okay, 1 is a divisor of 6. 1 is also a divisor of 12. 1 is also a divisor of 30. 2 is a divisor of 6. 2 is a divisor of 12. 2 is a divisor of 30. Okay, 3 is the same way, right? 3 divides all three of these numbers. But it turns out these are the only three numbers that are common divisors of these three numbers. 4 is a divisor of 12, but 4 is not a divisor of 6, right? 6 is a divisor of 6. 6 is a divisor of 12, but 6 is not a divisor of 30. Therefore, 6 is not on this list. Okay, so what I want to do is hand the function a list of numbers, and the function returns a list of common divisors for that original list. So let's think about how that function would work. How would you write a function that does this? Well, first of all, I'm going to hand that function a list, and it's going to return a list, because they're a given list of numbers should have, well, at least one common divisor, because 1 is always a divisor of anything, but it may have more. So you need to make sure you can return a list of numbers. Okay, so let's just talk through this with these 4 numbers. Suppose I want to hand the computer those 4 numbers. Now I want to think about computing the common divisors of that list. Well, first of all, we don't necessarily have to do this, but let's sort the numbers, just to make the list easier to look at for us humans. How would you find the common divisors of this list? The first thing you may want to notice, and again, if you haven't thought about arithmetic in a while, this may not be obvious to you, but anything bigger than 6 is guaranteed not to work. Okay? Divisors of a number are that number or smaller. So what I mean is, if you want to think about divisors of 6, you can't go any bigger than 6. Okay, 7 is not a divisor of 6. 8 is not a divisor of 6. They're too big. So if you sort the numbers from smallest to biggest, you have sort of a range of numbers you'd like to look through. You only want to consider the numbers 1 through 6. Anything over 6 is too big. So between 1 and 6, though, let's just see which of these numbers are common divisors. So let's just test. Is 1 a divisor of 6? Is 1 a divisor of 12? Is 1 a divisor of 24? Etc. Is 3 a divisor of 6? Is 3 a divisor of 12? Is 3 a divisor of 24? Is 3 a divisor of 48? Etc. So we're just going to march through these 6 values and see which of them are common and which of them aren't. The ones that are common we'll keep track of. And we'll keep track of them in a list. And then we will return that list when we're done. So that's how this function is going to go. So let's start writing it. So this function will look like this. Vector int common divisors. Oops. Divisors. And then I'm going to hand it a list. So let's now write this. Okay, so what should this look like? Well, first of all, let's create a list that will keep track of divisor list. That will just keep track of the common divisors. So at the end of this function, we're going to return that list. So of course, we need to fill in code in the middle to create that list. But we're going to create a vector that's going to keep track of the common divisors, and then we're going to return that list when we are done. So if you want to follow the algorithm I outlined in the slides, the first thing you should do is just sort the list so you know where the smallest number is. Now you know the smallest number is at the beginning of the list. So right here, 24, 12, 6, 48. If you start by sorting, then you know 6 is at the beginning. So the smallest number is at the beginning of the list. And again, if you're testing I values, you don't need to look further than the smallest value in your original list, because numbers like 7, 8, 9, 10, etc. are just too big. They are guaranteed not to work. So let's sort from beginning to end, and now let's just go through and check. Oops, sorry, start at 1. And let's keep going until we reach the smallest number, which we now know is at the beginning of the list. And let's just go one at a time. So again, this for loop, in my particular example in these slides, the for loop is running from 1 to 6. If the list were this, it would also be running from 1 to 6. I guess I should have used a different list here, right? But in this list here, if instead of 6 I had a 9, 9 is now the smallest number in the list, and this for loop here would be running from 1 to 9. Okay. Now what I want to do is, for each I value that works, so for each I value that is a common divisor, I want to throw that I value into the divisor list. So what I want is something like this. If this I value is a common divisor. What do I want to do? I want to throw that number, push back. I want to throw that number into this common divisor list that I am creating. Okay, so again, notice the computer is yelling at me. That's because I've written something here it doesn't understand right now. But focus on the big picture. What in English am I trying to do? Each of these individual I values, I want to test whether or not they are common divisors. So that's all I'm saying right here. If this I value is a common divisor of everything inside my list, I would want to throw it into this list I'm creating, this divisor list. So again, just for example, over here, think about 2, right? I just want to know, is 2 a divisor of 6? Is 2 a divisor of 12? Is 2 a divisor of 24? Is 2 also a divisor of 48? And if it is, if that's a true statement, all of those individual statements, if all of that is true, I would want to keep track of that by recording 2 in this new list I'm creating. Okay, all that being said, the computer, of course, doesn't know what I mean by this because I haven't created anything that teaches it what that means. But let's create something that teaches it what I mean by this. What do I mean by something like this? I want to have this list, right, this vector, and I want to test whether or not this individual I value is a common divisor of everything in the list. This seems to suggest that I should use a separate function to do that. And why not, right? Since this is a video on functions, let's write a new function. This new function will do the following. It's just going to check whether or not something is true or not. So it's a Boolean function. And all it's going to do is it's going to take an integer vector, call it whatever you want, and a separate number, and it's going to test whether or not A is a divisor of everything inside this list. So in other words, we're going to teach the computer what we mean right here. So let's just write code that does that. What would that look like? Well, if we just have a single number A, and we're trying to determine if that single number is a divisor of everything inside this list, let's just march entry by entry through the list and check whether or not A is a divisor of everything. So what does that look like? Well, let's say that A isn't a divisor of something. So I arrived somewhere in the list where A is not a divisor of that entry. Okay, so let's just make sure we all understand what's happening here. This for loop is just going to go entry by entry through the list. At each point in the list, we're going to ask, is A a divisor or not? And in this particular if statement here, we're asking, is A not a divisor? The thing is, if you ever inside of this list find an entry that's not a multiple of A, right, so A is not a divisor of that entry, then you know A is not a common divisor. Okay, so what is this saying? It's saying I'm just going to go entry by entry through my list, test whether or not this number A is a divisor. If you ever find a place where it's not a divisor, then it's not a common divisor because it doesn't divide everything, so you return false. But if you make it through that for loop unscathed, then you know that A was a divisor of everything, so I'm going to return true. And now I've taught the computer what I mean by this English here. So let's go back to the original function here. This is what I was writing to begin with. So common divisors, right? I'm creating a list of common divisors, and the way I do that is by going entry by entry, just I value by I value up until the smallest value in my list and checking whether or not each of those I values is a common divisor or not. If it is, I put it in this list I'm creating, and in the end I will return this list. Okay, so all that being said, let's now come back up here to main. Let's get rid of all of this. Let's create a vector up here and let's see if it does everything we think it should. So what did I have? 24, 12, 6, and 48. So 24, 12, 6, and 48. And now let's just create another vector, whatever. And let's let this be common divisors of this first list. And then let's print whatever the command was, print vector myvec. So let's see if this works. So again, this list is the list from the slides. So what we're expecting to see is 1, 2, and 3. Oh, sorry, and also 6, right? 6 divides everything because 48, 12, and 24 are all multiples of 6. So that's a typo in the slides. Oh, I didn't claim to know what the divisor list was. Okay, that's good. Okay, so it worked. And again, you can see how in main everything is very streamlined, right? All of this other code is sort of under the hood now, right? We've sort of separated it out. And another programmer could come along and just look at main and tell exactly what this program is doing, right? Because of the language I've used with regard to what the functions are called, right? So another programmer would come along and say, oh, he created a vector of size 4. Here's what the vector is. Oh, and then he created a new vector that was the common divisors of the original guy. Okay. And then he printed this new vector he created. So without even understanding any of this other separate code, right, we now have a bunch of functions floating around down here, right? Without understanding any of that, a separate programmer could come along and say, oh, I understand the big picture of what's happening here. So main is now very streamlined, right? And each separate subroutine has been separated out to be called on when you feel like it. Okay, so I hope that this video has made you more comfortable with functions and helped you see why they're useful, etc., right? But that is all I have for now.